We're live. Hello, everybody. This is Read the Source, episode 23. We have Sean Larkin with us. Hi, Sean.
Hey, how's it going?
And he's going to go through Webpack 2 source code. Please feel free to use @readthesource hashtag or mention on Twitter if you have any questions, or just place questions inside the commenting area if you need to be answered live. Otherwise, we're going to answer them later. So, Sean, your turn.
All right.
Amazing.
So I guess the best way to start is probably from the top level. But I think what's good is kind of to describe some of the high-level parts of the code. And so Webpack is built on entirely off of a plugin system called Tapable. And so I really want to start with Tapable first so that people can have the opportunity to kind of get the idea of the plugin system in their head. And it doesn't look like I have it pulled down, but we can break it open through node modules. So Tapable is kind of like event emitter in Node, except the only difference is that you can actually modify the state of the emittee, if that makes sense. And so let's just pull up Tapable through here. And so Tapable is actually a pretty harmless library. It's only, I think, 235 lines of code, but let's pull it up now. Can you guys see that on my screen?
Can you please increase the font a little bit more?
Absolutely.
If anybody is going to see the video in a lower resolution, then it wouldn't have any problem.
How does that look?
Better.
Okay. So Tapable in itself, like I said, is like event emitter, where you will go ahead and take a look, or you can create a plugin that implements one function on the prototype chain, or it can just be an object that uses the apply method. And this class here is actually something that you mix in with other classes to become kind of like event emitters, or tappable instances is what we call it. And so really there's a collection of various types of plugging execution orders. So like you can do it waterfall, you can do it applying them but bailing if one fails. You can do it as like an async series, which is kind of the same as async. And so there's a kind of a collection of these, the tappable prototype chain, that you mix into your existing classes. So essentially this is kind of the entire backbone of all of Webpack. And so I just wanted to give just a really high-level overview of what it does and what its purpose, because I'll be saying tappable instance probably a few more times. So I guess the way that I initially learned how to dive into Webpack was literally just start from, I think Dan Abramoff said, start at like the most simple part of the code and kind of branch out. And so I kind of took that advice and said, well, why don't you just start with the bin command? It's the first thing that executes. And, when you run Webpack in, the command line, or, from an NPM script, and just see what it does. So we can kind of take a look right here. This is Webpack.js, and it's essentially the binary executable. And, I can step through line by line, or I can just give kind of an overview. But what happens here is essentially Webpack is collecting arguments from the command line that have been used. And then there's also kind of a schema for these arguments to ensure that they're validated correctly. And so as you can tell, there's quite a number of arguments that can be referenced. And these are also used to kind of display in the command line as like a helper. So probably some of the most important parts are going to be where, let's see. probably starting right here. So this is where Webpack is actually going to require the Webpack runtime. And essentially, what this is doing is first grabbing the kind of like the compiler, and you're passing the configuration options to it. So in like a simple form, if you ever take a look at any of our guides for like our new guides on webpack.js.org for a new documentation, some of this code that you're seeing here is very similar to using the Node API, and it's kind of the same process. So the next part is that we've added in the latest version of Webpack 2 beta is the configuration validation. And so essentially we have an entire checker that's going to validate the properties that live on the schema and the configuration. If there are any errors, then this error or this class contains the error object and the handling for it. Then to essentially what will happen is if it sees the progress flag, so -- progress in the command line for Webpack, it's actually just going to take and apply a new instance of a plugin for a new instance of the plugin to show like progress in the console. Then the compiler callback is just a function that's extracted out, but it's the same usage as the Node API, but to take and use the stats object, which is kind of what you see when Webpack outputs like a result, and then the error handler for, let's say, if the build fails or like a watch fails. And so when compiler.watch is used, you can see that callback referenced, or compiler.run. So kind of what we're looking at here is essentially the usages for the the Node API. So I think that's probably the most useful place to start out. But I guess if we're going to look through kind of our dependencies, the first place we'd probably want to reference is under Webpack lib. So let's dive down in here to webpack.js. And so this is where the runtime is essentially going to start, kicking off everything.
Getting real.
It is getting real, that's right. And so we have the options object and then the callback, which is, like we saw in the Node API, going to be that callback that executes, and data will be passed to this, like the stats and the errors. So as you can see also, since it can add them to essentially...
Sorry, Sean, I think that we lost you for a moment. Can you please repeat the last 5 seconds?
Yeah. Can you hear me again now?
Yes.
Awesome. So essentially, the callback function is just like we saw in the usage from the Node API, is that callback getting past data like the stats object and like any errors that show up that are thrown. So you can see kind of like the first thing is Webpack is going to do some configuration validation, and immediately it's going to bail and not wait on any valid, or it won't continue to do the compilation process if there are any invalid configuration options in your config object.
Okay, so when we're talking about invalid, is this a strict set of options, or options that are unrecognized are ignored, or an error is thrown?
Yeah, so it's actually kind of a little bit of a combination of both. So the best way to look is actually kind of to take a look at our Webpack schema. And so that's found under schemas here in lib. And so this is kind of one of these new additions that really excited me because it's kind of, what we're trying to do is pave the way for, better usability across the board. And so having, a more strict and consistent configuration validation really ensures that, people are using the right properties. But not only that, if they're using the wrong ones, that we can help guide them to do the right thing. So you can kind of see here, this is using just kind of the JSON schema specifications. And So you can see here, for example, it not only validates that the property itself is valid. So only the properties that we list here in the schema are accepted, but also it will enforce like the kind of types. So if it's of type object, or if it should be like just a string, or it could be multiple different types. Kind of finding out. This was thanks to one of our community contributors. I think his name Gaius. He did a lot of work on this, and we were really appreciative. But it gives the opportunity to kind of validate the minimum amount of items, types, whether it's an array or it's an instance of a regex, etc. And so there, if you wanted to know exactly what the properties of everything should be, and we're trying to make this kind of a generative like document in the future. But you can go right to the schema to see what is accepted and what's not. And we're now, what we do is, this is part of our unit testing and integration testing. So if somebody tries to add like a new property or feature, it will error instantly upon the schema. So it's a good way of enforcing people to add, to kind of keep up and maintain the schema at the same time, if that makes sense.
Yeah.
So I guess let's jump back here. So where were we? The runtime. And actually, I'm going to sidetrack for a second, but you can actually use, I believe, Webpack in the web if you wanted to. I think I've seen this used before, but we had an online tool that allowed you to kind of build a dynamic configuration to some extent. And so I like sharing this with people that, hey, there's actually a web version that I believe will run on web instead of just Node. So, just a little, did you know? But anyways, so after we validate that, or after we ensure that the configuration is valid, then we go ahead and check first, is the configuration object that we're getting, is it an array of configs or is it just a single? And so the reason why is that we have a special class designed for doing multiple compilers called multi-compiler, or multiple compilation instances. And so this class will get invoked if you pass an array of configuration objects to the Webpack options, or let's say in your config. And if not, then it's just going to, as you can see here, it really just maps each of those options. So it's just running a compiler instance for each. And then otherwise, it's just going to do the new single compiler instance. And so the first things first is that we have what's called the Webpack options defaulter. I know a lot of times people will say, Sean, you guys don't have sane defaults. And then I kind of laugh because I'm like, well, if you take a look at this file, we actually are setting a lot of things by default for you. And so this Webpack options defaulter simply serves the purpose of taking an object and excuse me, and setting a bunch of properties by default. So dev tool, which controls your source maps, is false. It allows you to not have to set so many things explicitly. I think by default you only have to specify the entry and the output property in your configuration, and the rest is going to have just defaults for you. So that's what this options defaulter is. And so that is going to be processed first, and then we have our new compiler, and then the options are going to be set on the compiler itself. And then if we scroll a little bit down here, we're going to see a class called Webpack options apply. And so the reason why I want to highlight this is because it's kind of the first place, besides where some of this logic down here is specific to kind of exposing, plugins that you can require from the Webpack object. But I think options apply to me is probably one of the most important and kind of the next step. So if we look at Webpack options apply, for lack of a better term, it's kind of like a ginormous logic tree that that looks at each individual property that you've set on your configuration, and then applies different kinds of plugins to the compiler or the compilation itself. So now I did mention tapable before, so you can see that tapable is being required here, and compiler is one of the 7 or 8 Webpack tapable instances. So essentially, when you write a Webpack plugin, you know, I'll write one here in line for a second. So let's say foo plugin. Foo plugin dot prototype dot apply. You actually get the compiler instance. Passed back to you. And through that, the compiler will have a couple different properties that can also have either applied plugins, or you can hook into the events that they're going to emit. So when a tappable instance sees that it has plugins, it's actually calling the apply function for every single plugin in specific order. So if you're looking inside the Webpack source code, if you wanted to see where kind of any of the events are or the hooks exist, the best place is just to look to apply plugins. And so any of these parts are where the compiler itself is calling these hooks that plugins may be registered to.
Okay, so question is the order, it seems that the order of the hooks is really important.
Yeah, so like the hooks themselves kind of represent, you know, the life cycle. And so I think I had a list which had them in order, but like, for example, I think, let's start just right in the compiler itself.
Because my next question would be how easy is to extend, how easy is to add a new plugin or extension.
Oh, okay. So like, for example, the order, we can just look right here in the, I think I want to use just the normal, not the watch and go. So this is going to be one of the first methods that is called when the compiler runs. It's, you know, obviously called run. And you can kind of see here just a example of synchronous and asynchronous plugin hooks that are emitted throughout kind of the life cycle. And so
it has a strict life cycle.
It does.
Okay.
It does. But it is complex, but it is strict and consistent throughout every process. But it is extendable. So like, let's say, for example, I have a plugin. So like, we could call it compiler did start plugin. And let's just change my Java. Okay. Yes, I know. Let's just save the file on my desktop just in case. And so what we can see here is we get the compiler, and what we can do is, I don't know why that's giving lint, probably for style, right? Oh. So a typical example of this, so if I would actually call compiler.plugin the event name, so I guess let's say we wanted to do on the run hook, so let's say run. And then we can go ahead and let's see what it passes into us. So it passes the compiler instance, and then a callback for handling any errors. So we would say we would get callback. And let's see. compiler callback. Okay. So technically what we can do is if you wanted to extend the event system, you can do so by, let's saying, apply plugin, and then passing your own event because of due to the flexibility of the plugin system. So I could say after, or let's say like compiler did start plugin run. And then I can pass whatever I would like to. So let's say I want to pass that same compiler instance. And so that would be a synchronous event hook that you can pass in.
So is this going to be stacked or queued, the event list lifecycle?
So it depends on what kind of a plugins that you're using. So like this is a synchronous one, whereas these are going to be, they'll be stacked, or you'll see them in the stack. So once higher level asynchronous ones resolve, then it will continue kind of to waterfall as the callbacks continue.
Got it.
And so that's why you see here we have kind of like a little bit of waterfall of events. One of the things we're really excited to do is look into refactoring the plugin system just simply for readability. Because it can get, as you can see here, it gets pretty pyramid of doom, I guess we call it in JavaScript.
Yeah.
So anytime that anybody wants to hook into that event system, they can look at the event and then as well as kind of what data is going to be passed through, and then you can mutate that data or use it to do any additional functionality. So I guess back to the Webpack options apply. So that was so you can kind of see here, you're like, well, wait, Sean, like everything in here are plugins. And so that's the beauty of the system and why, essentially almost every plugin here is either dual or single purpose. And so based on the logic tree that we go through, so like, let's say if the options.target property, that's a good one because, like the Webpack Bootstrap template, as well as the, kind of different dependencies change based on kind of the environment that you're targeting. So let's say if it's the web, which is the default, you're going to get kind of the default loader target plugin. You're going to get a node source plugin, and but let's say if we go down to like Electron, we want to expose a bunch of function objects as externals. And so there's this logic tree in the plugin system makes it really flexible to kind of not only add features, but to kind of pivot away from different features if we need to. And so we can kind of continue down this logic tree as different options are getting applied. And then we'll start to see some different features. So like the output.library. So this is if you're using like the library target properties in your configuration. If you want to pass any externals, then you can see there's an externals plugin. And then, that is actually applied to the compiler object. And then, so there's a huge set of logic for the DevTool property. And the reasons being is you can have like up to, I can't remember what the permutations are, but there's, I think, 18 different permutations of source maps. And so this kind of block of logic that we have here allows for the different types of source maps. Here we go. And there's a couple different plugins that kind of decide. So it's like the eval source map DevTool plugin and the source map DevTool plugin. I found it, even though things are a little bit verbosely named, it's really helpful to identify kind of the purpose of the plugin and kind of track it throughout the code base. And then after source maps are applied, then it's going to go ahead and read the like the entry property or the entry option. And so that's kind of where the start of Webpack gathering it, or Webpack, the compiler is almost done gathering all the configuration and applying specific features based on it. And then anytime, so there's specific plugins for like sugar features, I guess I like to call it. So entry, or let's say you're using output dot, path. Like I'm just going to do this inline. Let's pretend this is a configuration object, and you have output, and then that's an object, and we pass in path. Or, I think maybe file name is better. So if you do path and you do, you can pass these kind of bracketed templated names. It's like name.bundle.js. This is pretty common and required if you have multiple entry points. Well, that's the purpose of the templated path plugin, where it actually evaluates kind of a series of regexes to replace and find specific dependency names for, based on an entry point and all sorts of different properties like chunk hash and hash, etc. And so finally, at the end, there are now getting the information or kind of setting some really important pieces like the resolver factory or the resolvers, as well as, so we have a couple different kinds. So there's normal resolvers, context, and then loaders. So you can have different resolution strategies, whether by default or if you configure it. And so that's kind of what this block of logic does, is where it creates a default resolver, but then if you have specified resolver options, then it's going to do kind of like an object assign on it. And so this applies to both, like normal modules and context modules. And I can dive into that if we don't run out of time. And then loaders have their own unique resolution strategy. When you use a loader in Webpack, you don't have to require it into your config. And so therefore, that's kind of one of the powers of Webpack's enhanced resolve, is that it has cases that handle this by default. Okay, so essentially, I think if we go back up, we could probably jump into the compiler itself now that we've seen all the options have been applied. So let's take a look here. So as the compiler is running, besides just the tappable hooks, it's going to create what's called a compilation. And so a compilation is going to be essentially the object in memory that's going to contain all of your dependencies. And so you can kind of see here where a new compilation is passed in this function, and we can kind of drill down. So there's a new compilation function, which is then called from, let's see, new compilation params. And so you can kind of see here that there's also some new kind of terminologies called context module factories and normal module factories. So we're getting pretty deep in terms of specific kind of nomenclature in the Webpack source code. But they all mean some very specific things, and I hope to, to clarify it. So let's see. So essentially, when the compiler compiles, it's going to go through and create a new compilation. And then really the purpose is to, a lot of this code is kind of a facade for, plugins to apply to. And so you can kind of see here that really a lot of this code inside the compiler is just tappable, events that are being emitted, and with the compilation being passed to it. Any questions so far, at least in regards to the compiler lifecycle?
Oh no, seems pretty clear.
And so I'm gonna dive a little bit deeper now into the compilation. So
please make it more complicated.
A lot of this, a lot of the complication in the source code is really to kind of help support the modular flexibility that we try and keep at the core of some of the values of the source code. But you're right, it does come with complexity, and I think one of the things that we really want to help fix, so like even small pieces if we can. So on December 1st, we're going to drop support for Node 0.12. And so what does that mean? Well, we can start using like classes instead of object-oriented ES5 JavaScript. So that's like a huge win for readability and structure. So I already have, contributors and myself, are going through kind of the smaller supporting libraries, let's say like tapable or enhanced resolve, Webpack sources, memory, FS, and we're converting those to ES6 classes. And so then that way, it's just kind of pushing that contributability or lowering that barrier, just a bit more each time. So now we're in the compilation. And so I guess the first thing you can notice is, oh, hey, Sean, look, it is a tappable instance. And you can tell, that a class in Webpack is tappable or, it is using the plugin system. Anytime you see tappable, call this. And I think also it's creating, essentially mixing in the tappable kind of event emitting functions from tappable onto the prototype chain. So let's just look at some of the properties that are in here. So a lot of these actually you will see if you're ever using the Node API or like entries, entry points, chunks, named chunks, modules, records. Errors and warnings are huge. And then there's also dependency factories and templates, which I guess I might be able to have time to cover as well. So I guess we know that resolvers were created in the compiler, and so those are added to the compilation, and you can kind of see that here, as well as the input file system. And we also have the options object that is picked up from the compiler itself, and it's referenced inside of the compilation class. So this is just kind of like the constructor of your class and kind of some of the setup code. I'm trying to think of what is a better, if we diverge and talk about templates, or if we get more into like the parser itself.
I would suggest to go into templates,
sure,
if possible.
Absolutely. Okay, so a lot of times in the Webpack source code, you're going to see things that end in template. And so main template, chunk template, module template. And so when Webpack refers to a template in the source code, it's referring to a subclass of something called template.js. And so as you can see, yes, it is tappable. You can hook into the event system. But what this does, so template at the top level is kind of a collection of convenience methods that help you not only find or get modules that are passed to it and render them, but then also render chunks. So like the template is best described is, I wonder if I can show a great example of one. UMD main template plugin. I worked in this code a little bit. So let's say if you use the UMD property, I'm going to make this just a little bit smaller so it's kind of easier to read. But
so just a second, whenever you're making the font smaller, just scroll slower because the screen renders slowly.
Oh, sure. Okay, I'll go slow here. So you can kind of see that there's a lot of like string manipulation and concatenation that's going on here. And the reason why is that, in the end, Webpack, what it does, or its purpose, is to take normal modules and wrap them for the browser, to give them that kind of module loading environment emulated for the browser. So to do that, we've created a bunch of abstractions to make it easier to consistently render, the format of your code, especially when it shows in the output. So for example, this code that we're seeing here, and I'm just going to jump to the top to see if it's okay. So if we look right here, this code actually is, besides the variables, what you would see in your Webpack output or in your bundle if you're using the library target UMD. And so what's happening is that we're using a bunch of different properties from these classes, as well as gathering input and then this itself is kind of the template for that part of the bundle in the Bootstrap. So the template you can kind of think of as the actual outputted code representation in your bundle and how it looks and how it's formatted. So if we jump back to the, I think, compilation, I guess we can go to template again. I'll zoom in. As
a side question, how often do you have to maintain, do you have to go back to those files to change if, I don't know, module loader changes, like MD?
So if we wanted to change the format of the actual, like the wrappers, there is a specific template for it. So I believe it's called the function module template plugin.
So there's a template for everything?
There is, absolutely. So like, for example, I created a, and you can extend this. This is probably one of my favorite parts about Webpack is that you can take and create a plugin that hooks into these functions. Because as I said, everything, you know, a lot of the code here is tappable. And so like template and I think it's called what, the module template, or if we were to jump back into, I believe, compilation. Module template is actually an instance of the module template class, which I know we have to kind of drill into different classes, but you can see here that it's a subclass of template, which is tappable. And so all of that extensibility is kind of inherited for any of these kind of templates here. So going back to the function module template plugin, what's happening here is that this plugin is literally responsible for creating the wrapper code, or the wrapper, I guess, you know, boilerplate, or the code that wraps the modules itself, and handles different parts, you know, based on whether or not did this module actually require something else. If it did, then we want to add a third function to it. If it did not, then we won't. Or and then it references kind of these classes that are called like concat source, and you know, and I can go into that. Essentially, they're kind of like object-oriented abstractions to kind of concatenating, replacing, and modifying the source that you're working with in just a little bit more of a controlled and consistent way. And so these are really nice because you can, with a concat sort, you can just do sort.add, and it's going to add to this kind of list of nodes, and it's then going to resolve and render all of the strings together to create kind of one source here. And you can see that. So yeah, essentially you can plug into almost any part of Webpack to change it. I created maybe I can pull it up if you're interested, but essentially a plugin called Lazy Parse Webpack plugin. And all it does is it takes and wraps, it wraps this kind of function template around. I'm just going to paste the code in here so we don't have to change the share screen. But I'll kind of paste it right here. But essentially what I've done is I plug into the compilation, which is kind of using that hook. And then I apply this template here. And then that template looks like this. It's a little bit long, but it's actually really similar to the existing. So if we look here, the only difference is, I believe, where did we add it? I added it right. It's like an extra parenthesis right here and right here. But what that does is it actually kind of it makes it so that when the browser engines parse your code, it will make it lazy parsed. So you know, some of the early statistics, you know, it was just kind of a proof of concept, but to optimized for the browser, and I think we saw like 20% gains in load times. But that's just one example, and there's a whole bunch of different extensibility kind of points that you can access. And so anytime you see something that's called a template plugin, you're probably going to see one function, which is apply, which will help you essentially join and modify the source, and then also package, which is the outer wrapper to that. And so the outer wrapper kind of allows you to add some kind of sugary information about it, but less about the structure of the actual module wrapper itself. And so that's why you kind of see a lot of the heavier comments and kind of meta information found there. So I guess diving out of that rabbit hole, you can actually see different templates for each. So like there's a chunk template, there's a main template. Even for doing like hot module replacement, there's a hot update chunk template. So what does the structure of that code look like, and how do we render it based on the dependencies we get? So diving in, essentially, the compilation is going to have a couple different pieces of information. So it's going to have functions that are used to add modules that are resolved from the resolver and loaders into the compilation itself. And then it also has the ability to find specific ones, just kind of some basic, search and fetch, get, add functions. But then there's also kind of more complex, but specific to kind of creating and resolving dependencies like the build module. So what happens here is that this module is going through and is passed to, you're passed quite a few different arguments here, but you're passed the input file system, so as well as the resolver, so it knows where to be resolving. And then it looks through the dependency and then catches any warnings or errors. And then any dependencies is going to compare those and sort them. And then you have kind of like your callback hooks.
So question, is it going to find all the dependencies first before moving on to the next step, or is this a on-demand execution of finding the dependencies?
It is. Actually, I'm really glad you asked that, because that's something I think some people don't realize, or is kind of a key difference between Browserify, is that the building of the dependency graph is kind of an imperative process as dependencies that are marked in your code resolve. And so like kind of the basic or the easiest way, or at least I've heard people describe it, is like this. So it's resolve, transform, and then bundle. So at the end of this portion, there is kind of a dependency graph that you can use, but really it's a very imperative process, and it's kind of on demand. And that's what allows for, we do it for a couple of different reasons, but kind of one of the main ones I believe is for speed or performance. So you can kind of see here how module dependencies are getting added. I mean, we can kind of jump to where that happens. So like add module dependencies. And that's as they're getting processed, and we can kind of drill. This is kind of, how we take and, how I've learned the code is literally just by drilling through these functions. But you can see here, it is recursive. So it's going to add the module dependencies and then process them. And then if it finds dependencies in it, it'll kind of repeat this step. I'm going to just mute as I have to cough. Excuse me. Okay.
No problem.
So there's also some functions that are kind of like convenience or extensibility functions that have been added for different purposes. So like there's an add entry function where you can actually hook into the compilation. I can't remember what the hook is, But we suggest in our old documentation, hey, if you wanted, this is your last chance to add some entry points or, kind of add additional things to your dependency tree. And these are kind of, some of those functions that are mentioned that you should use. Because really, you don't create synthetic modules in Webpack. It's all an imperative process through that dependency graph and the imports and the require statements or whatever else that is declared as a dependency is processed. And so some of that kind of leads me on to talking about the parser itself. But you can kind of see here there's a whole bunch of different plugin hooks. And a lot of these are just kind of async. But have very specific order so that people can optimize different things. Like certain properties are added, and so it's a little bit controlled in some regards. But for the sake of being able to, like let's say I'm trying to think of a good one, a good plugin that kind of optimizes occurrence order plugin. So this plugs into optimize module order, and you get all your modules. And then I believe you pass like a predicate that will sort through each, sort your modules in a specific way for performance. And I think it's like how many times does it occur, etc. And you can kind of see just the same thing. What's relieving to me is that I always am comfortable with the code structure because I know it's going to be a plugin and I know what key things to look for throughout the code to know where it's happening in the lifecycle. So, we're plugging into the compilation, the optimize module hook, and we get modules. And so there's some kind of like sorting algorithms that we're applying here. And then, we're sorting the modules themselves. And then in the same way, this plugin will also optimize the chunk order. So, this is another hook that you can just get chunks, but kind of the same thing where you will kind of have some algorithms that will do some occurrence or find out how many occurrences there are. And then it performs that sorting predicate here. So that's kind of what, an example of some of these are. And, there's a whole bunch, and they can be really powerful and kind of help and add additional functionality for certain parts of that life cycle. And so the next kind of part, and I think I kind of skimmed over it because it is used, let me see, normal. Where is it? There we go. So there's the normal module factory and the context module factory. This is probably like one of my weakest parts of the code, but I think it's important to just kind of describe at a high level what's happening. And so, the purpose of this class is to hook into the resolver, resolve the request that has been made. So like a require statement from your JavaScript. And then, or actually, I'm sorry. So really what it's resolving is something that's marked as a dependency. Because, in Webpack, you can require CSS. But if you require a CSS file and it has like a background image URL, there's a loader that can actually say, hey, mark that as a dependency. And so essentially, any marked dependencies are going to be resolved first. And then if they successfully resolve, then the next part of the module factory is to create one of these normal modules. And so I actually added some comments beforehand, so it's easier to understand. So like this normal module class kind of gets some information from the resolved result. And so you might have the actual request. So this is good to reference for like logging and things. The resolved user requests, so like before loader transforms are applied. So like I said, it's resolve, transform, and then bundle. So this is before that transform happens. And then the loaders themselves that, let's say, match the dependency of choice. And then the actual parser itself, our parser instance. And I'm going to go into that here pretty quickly, because that's probably one of the most powerful features of Webpack. And and make it extremely flexible and granular. So let's see how much time. Oh, so we're almost running out of time. Let me know if you want to cut me off and take questions or anything.
No,
so,
we can extend a little bit more.
Sure. I mean, we could spend a couple hours if you want.
We can do a second session if
Sure.
you wish, so we can do it next week or something after that.
I mean, really, if the people are liking what they're hearing, sure, absolutely. So the second part, so like I said, resolve, transform, and then bundle. And so these normal modules have kind of the instructions on how they need to be processed now, and then where they came from, and a little bit of meta information, as well as the parser. And this parser is actually a tappable instance that uses Acorn behind the scenes to parse the AST of the transformed JavaScript. So let's go down to, I'm just going to go down to a specific part of the code. Let's see, where is it? Resolve request array. So you can kind of see that it actually gets a new parser instance and passes that on. But a lot of this code here, or the most important, is found right inside of, and I'll try and go slow, is inside resolver. And so what's happening is that this is the kind of the resolver process, and it's generating based on the information from your loaders object, as well as kind of the default resolution. And what happens is that loaders are executing in parallel. So for any type of request, it's going to execute in parallel not only the preloaders, but then also our post loaders, as well as our just kind of the normal loader objects. And then what happens is that really the transform doesn't happen just yet, but it returns kind of like a concatenated result of one string that represents your entire resource or that module and the transforms that need to be applied. But then after that transform happens, you always in the end you're going to result in JavaScript. And so Webpack only understands JavaScript. Doesn't necessarily mean that it's going to be added to your bundle. Let's say like in style loader, that code actually takes CSS and transforms it into a script, transforms it into JavaScript that adds a script tag to your browser. So it's kind of thinking in the way that in the end everything is JavaScript to Webpack, and that's kind of where the parser comes into play. So if we dive into the parser, so we're getting a little bit on this I call like the low. It is tappable and it uses Acorn. So Acorn is an AST parser or a JavaScript parser built in JavaScript. It's comparable to different things like Esprima, Babylon, etc. Acorn itself also has a really unique plugin system. It's been contentious in the past where some say, well, that's kind of why it can be slow or hard to maintain. But I think that's just a matter of opinion. We went with Acorn, and so essentially, you can see here that what happens is that the parser uses Acorn to walk the entire tree of every module that you have after it's been transformed to JavaScript in the end. And so all of this logic here, not only plugging into Acorn's kind of event system, but also emitting plugin hooks for each type of AST grammar that's walked in the tree. And so if you really wanted to get crazy, you could say, you could write a plugin at the symbol level for any of your Webpack code. So like if I wanted to write a plugin that says, look for evaluate call expression dot replace. You could hook into that process and you can get the expression itself and the params. And then you get that expression and can do some augmented features or, emit some events yourself, or replace the module template for that dependency. I mean, you can do a whole bunch of different things. And so really, all this code, I mean, it's extremely lengthy, but what it's doing is it's essentially just walking different types of declarations. And so you can see here there's walk export default declaration. There is, I think, let's see, like walk export name declaration. And this is kind of where some of the power of, this is what makes kind of tree shaking possible. And the reason why is because Webpack knows every sort of dependency for each of the different types of CommonJS or ES6 imports and exports. So you may be wondering, like, why would anybody want to write plugins for this kind of stuff? And so that's actually why we have a folder called dependencies. So inside of our Webpack source code, dependencies is specifically devoted towards any type of dependency that can be parsed, that's walked kind of through this tree. And so you may say, like, you may see AMD, Common.js, Harmony exports and imports, Harmony modules, require ensure, require context, require include, system.import or system import. So all of these is how Webpack can support all of this different functionality. So like we could look at one that I think is a little bit easier to understand, like the system plugin. So in Webpack 2, you can use system.import to create code splitting. And so, for anybody who doesn't know what code splitting is, essentially it creates a mark point in your code to lazy load whatever resource you request inside of that import statement. And so it not only lazy loads it, but puts it into that Webpack kind of wrapped template environment. And so what's so, when I finally figured out how this worked, I feel it sounds silly, but only a few months ago, you can actually look, once you understand the parser itself, or, kind of the plugin system, you can see right away. So this plugs into the compilation, and then the normal module factory where the parser lives, because we saw that parser is on the normal module object. And then on the parser, you then plug into different types of expressions. So like what's really cool is that you can pass like a string concatenation with a variable. So you could be, if you ever wanted to, I guess technically, let me see. In this case, I guess this will do like an iteration once we look at set type of, but you can, essentially make like one hook and then kind of iterate over it. But yeah, so like this is what it's doing, is it's putting a hook on evaluate type of system and equal to object. So essentially it's looking for that, evaluation in the AST, or it's looking for like system.import, checking if it's a function. If it's not, then it's going to error, or it's going to say it's not supported. As well as, we have some parts of the system.js, kind of loader spec not implemented, like set, get, and register. And so, we use that as well. So like set not support type. So we're checking it again. And, we set, we basically say this is not a dependency, and, set the string to undefined and the range to the expression range. And, we'll emit a warning just saying, hey, this is not supported. So if we wanted to dive a little bit deeper, you can see there's a system.import parser plugin that's applied here at the end of the code. So if we look inside.
So I have a question though.
Yeah, go ahead.
In the code, so I'm going to click on this so everybody can see the code while I'm speaking. The question is, anybody can write its own parser, right? Then can we extend or create new parsers?
So that was actually something I've been doing a lot of exploration on. You could technically, so like for example, Arya Hidat, who authored and maintains Esprima, you can actually swap out different parsers, but given that it uses the same kind of like family of parsing AST syntax, so like ES tree, I believe it's called. So like Esprima and Acorn are both under the ES tree family, and so they can be swapped out. I think I have like a branch somewhere where I think it passed, or Aria was kind enough to give me a .patch file and apply the changes, and it did work successfully. But like certain things like Babylon uses a different AST, and so wouldn't be able to support it, or like, but the benefit is like, let's say if you wanted to add like some extra features, I don't believe there's extensibility in this case, like that you can, let's see, tapable. You can actually get the whole program. So like you can get the entire program of like the AST of your code. But I don't believe you can plug into like the configuration system. So like this right here.
Yeah, you got it.
But I do know that you can write Acorn plugins. And so like what's been really, nice and has some flexibility is like, let's say if we wanted to implement, we're not planning to just yet until the spec finalizes, but we're thinking about migrating from system.import to import. And so, what we would need to do now, if we wanted to do it now, is we'd have to write an Acorn plugin, and apply it, but then just kind of add some of that configuration to Acorn to make it possible. And here's some other like possible AST options. You can do that stuff right here. But jumping back into like the system, where was that? So system import parser plugin, you can see here that this is literally plugging into the parser for just system.import, and we know it's a function. And then it takes and it looks at the expression, what's inside of, and then inside of the dependency block. And so basically what happens here is Webpack is taking and it's applying a couple more different classes. So you can see the dependency block and some helpers. Probably the most important part is the dependency. Let me see, what's the better one? Probably the dependency itself. And so dependencies in Webpack, all of these are called dependencies, but they have a feature, which is the template. And so like I described to you, each dependency has its own template that you can describe how it's treated. And so in this case, for system.import, we want this to be an asynchronous Webpack call to another chunk that returns a promise. And so as you can see here, we're taking the source or the expression, replacing it with, with some ranges here that are passed from the arguments, with actually the promise code, and then a .then, and then using the kind of Webpack require system. And so what's really awesome, at least it's exciting to me, is that let's say if we wanted to add the import, all we'd have to do is just add a new plugin and then maybe add deprecation warnings to this one and basically saying, hey, we're migrating over. So the level of impact is so, because of the granularity, the level of impact is so much less. At least that's one of the benefits that, in my opinion, with this kind of modular system. So like there's, you can spend, a whole bunch of time looking into the dependencies themselves, as well as kind of the dependency templates if they're more complex, as well as, kind of how Webpack treats every type of, kind of dependency statement. So like a require, an AMD require, a import, a default import, and there's a parser plugin for each of those. So like here, you can see that there's even some for hot module replacement that's supported as well. So once the parser goes through and So this is like still just part of the, I guess you could call this part of the bundle process, or between transform and bundle, where Webpack is now taking modules and their dependency requests and kind of collecting all the dependencies and applying their templates inside of the chunks. And so then that way, you know, like a resulting bundle may look like, I wonder if I have one inside of our test code. Expected. Trying to think if there's a good one. There might be like template cases. I would assume we would test against that. Let's see. Fixtures. I can't remember where we have that. If we do have like just an example, I can just pull one up. I don't see why not. There's a huge benefit to it. Oh yes, I know where. I just skipped over it. Okay, so like let's say a good example is like system import or Harmony. I think it's like Harmony async is what we call it. So Harmony code splitting. Here we go. So here's an example of the usage. And so like for anybody who wants to know kind of how some of these work, please take a look at our examples, because we not only show that, but we show the README, which is kind of a generative README, but it actually shows what the resulting JavaScript will look like. And so in this case, anytime we use that import, it actually creates a separate chunk. So it's marked as a separate module here. But then also you can see all of these things right here. These are dependency statements that were transformed with the template and the parser plugins. And then we have like the promises that are returned, Webpack required.e, which kind of means ensure or async. And it's just shortened for compression and size. But then you can kind of see here, it requests the module, which is 2, and then returns a promise with the Webpack require statement, binding it to the actual module itself. And then I think it looks like this case, it takes that actual module code, which says loaded B, I think. Loaded. Yep. So I think.
Can we see the actual build JavaScript file?
Yeah, let me pull it up. So like this is the build JavaScript file, but it's easier to be read through like on our source code. So let me take and I'll just switch the share screen over so you guys can see it. I think there's benefit to seeing the markdown in a little bit prettier fashion. So I'll jump back over. Let's pull it up right here. Okay. And you can see that browser, all right?
Can you please zoom in a little bit?
Yeah, absolutely. So it's nice to see the template. We can go into the examples and code splitting Harmony. I should just add a markdown viewer to my VS Code. But there's also sometimes some useful descriptions that Tobias or anybody else contributing adds for specific dependency cases. And so like, for example, here is the code. So example.js, we have a normal Harmony dependency. Like, so I think about it as what kind of plugins they are in the code themselves. So I see import A from A. So this is a Harmony import dependency because it's using the ES6 import. And then this is a system.import or system import dependency because the parser scans this and says, oh, hey, looks at the expression, it marks this as a dependency, and that dependency goes through resolvers. And then, so in this case, this is where the code itself, which returns those promises are returned, and then the module functionality is used itself as well. So the resulting bundle, So we always kind of collapse the Webpack bootstrap, but I think it's valuable to take a look at. So you remember how we talked about like the template or like the main template or the chunk template? So this is actually one of those templates that gets built, and this is the bootstrap, which has all of the loading information for the Webpack environment. And so you can kind of see here, there's everything from the JSON-P functions that are defined for doing requests to other chunk files or bundle files, whatever you'd like to call them. We call them chunks inside of Webpack. And then as we go through here, there's also things that you can read and kind of see how the different requires work. So there's a asynchronous one, which is your require ensure, but it's called .e. And so it's looking for essentially I think it starts the chunk loading by adding those scripts of the actual chunk itself. And then, and some of this is based on configuration. So like, let me see here, like output.js. I think that's part of the, you can change that to a different name. And then that's appended to the head of the DOM. And then, the promises are then resolved for those chunks since they're asynchronous. And then now that code is accessible, and we'll see that down below. And then there's some other ones. So like just a normal module that has not been cached yet. So like this is just a request. And then there's one for, oh, this module's already been requested. So we're going to use a webpack.c, which is a cache module. And then this is some specific functionality for ES6 imports, as well as getting different properties and compatibility. So like this kind of helps support that kind of mixed common JS, AMD, and ES6 environment. And then as well as, let me see. So this is handling errors for async loading, a public path property, which allows you to kind of specify a root path besides just the root, similar to like base href. And then, has own property. So I guess this is like checking for different, I've never actually worked in this specific part of the template, so I'm not sure what the .o does besides calling has own property. It looks like that's what it does. So if we want to now take a look at the code that's been created. So let's see, I'm just going to scroll up again. Let's see. This will create one. So we'll have a normal and then an async. And then another async. Okay. So we should have a couple different file, or I think it's probably all bound together. It is. Okay. So we can see here in our example.js code that now we've seen a bunch of different transforms. So we know that this was the Harmony import that I saw. And what's nice about your unminified bundle is that it can be really informational. We provide all these comments to say, hey, this was a Harmony import. Its name was A, but the actual module ID is going to be 0. Because outside of the Webpack bootstrap code, which is kind of separated right now, really, the modules are just kind of an array tapped onto the end of this function. As you can see here, it's passed as like a iffy. But beyond that, we can look at this transformed code and see that it's going to do like a Webpack async require to an additional file which has this code, as well as doing any of the resolved promises from our system.import. I'm going to cough for a second. Excuse me.
No problem.
So I hope that makes sense. So I probably threw so much information at you guys. It's kind of just scratching the surface. There's so many. I see the value in going through the individual source, and I didn't want to go too high level and really kind of stick to the code itself. So I guess this maybe is a good stopping point for questions or anything like that.
That was awesome. I haven't seen anything on Twitter, but I do have at least one question. So let's say that what suggestions would you give to somebody that wants to contribute to Webpack?
Oh man. So my first suggestion is just to reach out. Let us know. Because if you're unsure of what you want to work on, we want to provide like kind of that guidance and say, what kind of experience do you have? Is this your first commit? That's awesome. Here are some, available places that we need help. The thing that, one of the things that's at Webpack's core values is that it does not matter if you have one commit, if you have 10,000 commits, if you've been developing for a year or whatnot. We want to have your help and support, and that the only thing that we care about is that you give a shit about Webpack and wanting to, that you'll do a good job with, your pull requests. And so I always tell people, never be afraid to reach out, because we'll find something very specific to your interests, your needs. Like for me, I don't have strong algorithmic skills. And so like doing things like optimizing modules and sorting and working those predicates, that's not something that's strong for me. But I really understand the template system. And so working in that is comfortable. The plugin system itself is something that I'm pretty comfortable with. But I guess, like, for example, best place to start is to look on our GitHub or reach out. It doesn't matter. I always tell people to reach out, but you can go to, and I'll just pull it up. So we can go to the Webpack GitHub repository, and then go to boards or projects. And then we have actually like a help wanted one. I have to go through and update it just to make sure, but this will contain kind of a list of, kind of possible features or bugs that you can help us work on that we can't, prioritize ourselves. And then there's also like 1,000, not necessarily 1,000, but we have over, how many repositories do we have in here? We have like 30-something different repos that are either devoted to our core loaders, or they're also like plugins themselves. And so like if you want to contribute, you could even help us maintain or write documentation for a specific loader in the repo. Or let's say, our new documentation webpage, which I'm super excited to almost be finished. So like, this is the new kind of webpack.js.org. And, we've kind of revamped everything in the experience. We wanted to give first-time users, which never existed before, an awesome kind of user journey as they're learning Webpack for the first time. Because, I mean, even the code reflects it. It's endless in its potential and capabilities. And so we want to find, explain the why, the how, and, what are we trying to accomplish and what are you trying to accomplish? And here's how you can do that with Webpack. So like there's that. If you wanted to contribute to that documentation page, I think we're almost done with our milestone, like 92% or 86%. Where is it, milestones? Oh, so yeah, 88%. We have 3 issues open, and that's it. And so like if you love APIs, or you want to help us, document the loader API or the plugin API, you can help out with the, these as well. I'm trying to think of anything else. If you want to, go ahead.
Do you have any documentation and README file or something about what are the necessary steps to do before doing a pull request?
Yeah. So a couple things. One, we have a pull request template. So like when you create a new pull request, you're going to see some information that we want to see. And if you fill it out, it's going to be really helpful for us to expedite that process. And then the second thing, let me see. So if we jump back into Webpack, so let's say if you just want to do a pull request for contributing, we have a contributing doc that kind of gives the example of how to get started. We use Yarn for convenience and for build, CI consistency. And so you can take a look at this, use the commands. If anybody ever has any struggles through them, just reach out to me on Twitter, or if you even have an idea to make the contributor workflow better, like that's also stuff that we would love to see. For our documentation for webpack.js.org, we also have a contributing guide, so like kind of how to get set up. And then we also have kind of some directions on how to write as well. So like, where is it? I think it's in our writer's guide. Let's see, where is that? I feel like we have, oh, I believe maybe we actually published the document. So if we go to the index page, I think it's somewhere around here. Writer's guide. I don't see it. I feel like I know it's on here somewhere, but you know, I can kind of post. I'll make that obvious in the README so that people know kind of, you know, how to contribute that information, and, you know, what kind of style we're looking for in the documentation. But as I always say, get content in, and, you know, it can be quick and dirty, and then, you know, we'll help you through the pull review process to kind of iterate through the content so that it's a little bit more consistent with, you know, kind of how we're, you know, hoping to display that. So like there's, I guess if we go to content, they're all markdown files, and it's pretty easy. I worked on a lot of the concepts portions. And you can see here, it's just some markdown with a little bit of custom formatting and tables for display purposes.
Okay. There's nothing else from me. I see that we have no questions. Let me check the YouTube video. So that was amazing. Thank you very much. It was really an experience.
Thank you. And I mean, I hope that it can kind of be a little bit heavy in terms of the terminology, and I'm sure that I maybe messed up an explanation or two, and I know some of the members of the core team are watching, so they'll help me. Yeah, I'm just like, you know, everybody else. We're still continuously learning, and this is a huge code base in terms of modularity and complexity. And so, you know, if anybody ever has any questions or wants to reach out about the APIs or wants to help contribute to documenting them, we are more than happy to have that help. So thank you for having me on. And if your readers really found this popular, or folks found it popular, we could do a version 2, and we can cover like the resolver, the loader runner, as well as kind of Webpack sources, which is kind of some supporting libraries behind the scenes.
So we're going to reach out to the community and see their opinion about, their feeling about how much they learn and how much they want to learn more. Absolutely. And we're going to come back to you with an invitation. So thank you very much. It was awesome. And yeah, thank you for the viewers. See you next time.
Yep. Have a good one.